Today, we will be discussing about the differences between stars and planets. Stars are celestial bodies that produce their own light from internal sources. Stars produce their energy in the form of heat and light through nuclear fusion reactions. Planets are celestial bodies that are round, clean their orbits using their gravity, and they orbit stars. Planets don't emit any light. Instead, they can only reflect the light of stars. Let's talk about mass. Stars have much more mass than planets. For example, the Sun is 330,000 times more massive than Earth. Let's compare the Sun with a larger planet. For example, Jupiter. Jupiter has a mass of 1.9 septillion tons, but the Sun is still 1,040 times more massive than Jupiter. Proxima Centauri is a very small star. It's the closest star to the Sun, but it's still 129 times more massive than Jupiter, proving that stars have more mass than planets. Stars are not always larger than planets. For example, the star EB LM J055557AB is a star with a diameter of 118,000 kilometers, which is actually smaller than Jupiter. But stars are more massive than planets. This star has 81 times more mass than Jupiter. Although this is not mostly the case. The Sun has about 10 times the diameter of Jupiter. And the Sun is just a medium-sized star. For example, Stephenson 218 has a diameter which is estimated to be about 2.9 billion kilometers. Then the night sky. Planets Venus and Jupiter, and sometimes Mars and Mercury, outshine all stars except the Sun, which is actually because they are much closer to Earth than any star in the night sky. So, if stars and planets are very different, what is the similarities then? Well, Jupiter is composed of almost the same material the Sun consists of. So, stars have enough mass to maintain nuclear fusion in their core, but planets don't. So, what if something had a mass in between? In the year 1995, an object was discovered and named T-Duan. This object is 50 times the mass of Jupiter. T-Duan is a brown dwarf, too massive to be a planet and too less massive to be a star. Brown dwarfs' mass range from 13 to 80 Jupiter masses. They can't fuse hydrogen into helium, but they only fuse an isotope of hydrogen called deuterium into helium. And since the amount of deuterium is very low, they cool down and become very dark. Some less massive brown dwarfs like Gliese 229b are only 20 to 30 times more massive than Jupiter. Did you like this video? Bye, see you next time.